This is a typical Calculus 1 problem where you're given certain information about a function, its derivative, or the second derivative, and you have to answer questions about the other functions. Now, what I have below here is a graph of the original function g of x. And I need to answer these three questions. So I want to find the values of x for which g of x equals 0. So here's g of x. And I want to find x where my output is 0. So you have to think to yourself, okay, find x where g of x equals 0. So that means the output is 0. So the only place where output is 0 is along the axis here. So it looks like I have g of x equals 0 when x equals minus 2. X equals 0 and x equals 3. X equals 0 and x equals 3. So the place where g of x equals 0 is also known as the x-intercept. So when you're given the graph of g of x, okay? So that's kind of a college algebra-y question, for lack of a better term. Now the next question says, find the values of x for where g prime of x equals 0. So g prime of x is this first derivative. Find x where g prime of x equals 0. Well, we call those things where g prime of x equals 0 critical points. And if you think about what critical points do, critical points tell us where local maximums and local minimums of g occur. So you know our critical points are going to occur where g prime is equal to 0. So I have a local min here, a local max here, and a local min here. I also can see that if I draw a tangent line at each of those 3 points, the derivative is 0 there. Slope of that horizontal line is 0. So there's 2 ways of looking at it. So it looks like if I tag down here, it looks like I have, try to draw them as vertical as possible. Looks like I have g prime equals 0 at x approximately minus 1.2, positive 1.2, and 3. Even though this is touching the axis, it's still a local min. Now the last one is the values of x for which g double prime equals 0. So, can't really see this, 3, where g double prime equals 0. Well, we know that the second derivative equals 0 where the original function g has inflection points. So that means a change in concavity. So this is inflection points of g. So inflection points of g, I mean, you kind of have to eyeball them, but you can kind of see it's concave up, and it turns concave down somewhere in here. You know, maybe we can say x equals 0, approximately equals 0. And x looks like it changes again somewhere around 2 as well. But I go from up to down, so there's 1, down to up, so there's a second. So these are approximations here because we don't have any more information about the graph. But that's how you can look at these things. You always have to stop and think about what, if this is true, what is that giving me information about g? And in this case, you just look at the picture of g and use it to answer the question.